Okay, so in 20 years I will do like the presentation OPC UA on Mars. I heard there's some activities to go there, and maybe we send somebody with him. No, not Uni. We need Uni here. So to look a little bit in the future, not back like my last presentation. I was first involved in that project with Airbus in 2016-17. And at this time, it was like more a traditional use of OPC UA, like just front-ending some protocols and providing data to HMIs in their ground control. And then 1.5 years ago, they contacted me and said, oh, we want to do a little bit enhanced stuff. And they explained what they are already doing. And I realized OPC UA was already in space at this time. And I send a email to my developers and say, your software was in space already. And I never got that much positive feedback on emails to my developers like this for this one. And since then we say, like you heard, maybe OPC UA is from sensor to cloud. Now it's also down to cloud from space. So I will explain a little bit more details on that. So you heard my previous presentation, so you know what I'm doing with OPC. Like Unit Automation is more or less a technology provider. So a lot of OPC UA products have our libraries embedded to enable the product to use OPC UA either as client or server, and now also with PubSub, and then in the future also with OPC AFX. So we're heavily working on that part. But like today, I will show you how it's used in this space story, and that's the stories with Airbus, Airbus Defense and Space. You probably know them from the planes. At least I took 2 of them or 3 of them the last 2 days, going from Germany to Oslo and from Oslo to Helsinki. I think that was all Airbus 320. But they have also like a huge aerospace and defense department. So they say it's the largest one in Europe. What they are doing is as that project is called Texus, so it's technology experiments in zero gravity. And so this is especially like a rocket to have experiments in the minute range in zero gravity. There are other platforms they use and provide, or like ESA, the European Space Agency, is also providing. But this is explicitly about experimental experiments that's flying in a rocket to space and stay there for several minutes. So what they do today is they use OPC UA both in the flight software, in the rocket itself, talking to the ground system, and also inside the ground control, they heavily use OPC UA. And I will explain that a little bit more detailed, and I have probably more details than in the public case study. So I will tell you where you find this case study on the OPC Foundation website, but I have a few more details about what they are actually doing. So the general thing they provide is this is just one of the platforms for zero gravity experiments. And I cannot really tell you a lot about the experiments. I'm not an expert there. But what they have is there's for the shortest period, they have a free fall tower in Bremen, which is, I think, operated by ESA. Then you have these Airbus parabolic flights. So in the free fall tower, you have just a few seconds, 4 seconds, zero gravity or microgravity. In the Airbus, it's 20 seconds. And in the rocket, it's 6 minutes. 6 minutes still sounds short time, but it looks like it's worth the effort. And then the next extreme is on the IIS, where you have like longer time. So some people fly up just for a few days and then stay 3 months. So I assume the experiment duration is a little bit better planned. But like I said, this is the extreme to be like longer in space on the IIS. But in theory, the concepts work for all of them, and even the latest developments were related to IIS use cases. So for the rocket itself, the rocket is 13 meters long, and the payload they have 4 experiments they can put into the payload, and the payload is 5 meters, and the flight time, the complete flight time is 15 minutes, and they reach an altitude of 260 kilometers, and the zero gravity phase is 6 minutes during that flight time. So it's a relatively short flight time, but if you listen like all the news, you learned a lot about war rockets used in wars, so they can have a very short flight time, and they recover the complete payload. So the complete the flight time is just 6 minutes, but the complete project time, where they need to talk to the experiments and to the flight software, is more than a year. So they have typically a year preparation phase, and then when the experiments are back, probably the real work starts for them. So there's also like a lot of communication and a lot of information exchange before and after the actual flight. So when they started with OPC UA, they mainly used it as like the original plan was to just like a typical OPC UA use case, your front end, an existing protocol with OPC UA to have an easy integration into HMI systems. So and that was like their starting point was to provide scientists an easy way to create their own displays for the operation of the and analytics of the experiments during the flight. And as you all know, from industrial automation, a typical HMI is what is built for is to easily create custom displays, and that was their starting point with OPC UA. But they also quickly realized in the first phase that if they have a lot of different data sources, they probably need to do some aggregation of the data sources and do some information modeling to make it even easier to build the displays. So they used the product of us, the UA Gateway, to aggregate all the sources and to import, to build their own information model. And they have even like clients that write data into the information model. So it's not only aggregation of servers, it's also allowing clients to provide input for that is then distributed to other clients. And then like I said, the main use case was to connect different development, engineering, and science stations to that information, and that is during preparation of the flights, but also during the flight and after the flight. And so the second step, and that's where they contacted me, that was the state where they contacted me, is they replaced their protocol used between the flight software and the ground with directly using TCP/IP and OPC UA. So they integrated OPC UA servers directly into the experiments, into the flight software, and they still used some adapters because not all experiment containers had the OPC UA server in the first step, but that went away over time. So it was just also intermediate to have the adapter fly with the rocket. But like I said, the communication to the ground that was then already completely OPC UA. And that was the time where I told my developers, your software is flying in space. And that was already to them. You will have like some more details on my last slide. This is the program manager. the pure Ethernet capability was already for them a big step forward. It made everything much more flexible and accessible, also remote accessible for scientists. So you don't need to be always on site to do some preparation. And if you think about a year preparation, it's painful to always have to fly to where the system lives to prepare everything. And this is what they contacted me was they had like in the IIS environment they use like a cloud system, and they also have the problem that there is no TCP/IP communication that you can use to the IIS. They have just a one-way communication so the experiment can send data down to the ground control, but there is no way back. So they can use only UDP. So they asked, what can we do to solve like the cloud connectivity and the one-way communication thing? And I told them, oh, we have something nice for you. It's called OPC UA Pops Up. And the good thing, it was ready at this time. So we worked on that like the 3 years before, and was just ready when they asked for it. And so that was the first thing to be able to send data also to the cloud application, and then like displays that work with the cloud environment can also work in the same environment with the experiments. That was the first thing, but then they also realized, okay, sometimes they have like bandwidth problems with their communication from the rocket down to the ground. And with TCP/IP, then you have your retries and you get delays and whatever. And so they looked for a second option to have a streaming of data with higher throughput. And so they then also used Pops Up with UDP from the flight segment to the ground. So they stream now the telemetry data using Pops Up from the flight segment to the ground segment, and they use client server mainly for commanding now. So to change maybe set points during the flight or to do some adaptation, and so that gave them even like better throughput on or higher reliability with lower bandwidth communication. Like I said, this is their current state, and they at the moment they have, I think, the last flight that was like this March, they used Pops Up already, but they have not all of the experiments can already send data with Pops Up. So they also use the UA gateway in the flight system, in the flight segment, to publish data from servers that didn't have Pops Up integrated yet down to the ground segment. So they take the data as client server in the rocket and then send it down with Pops Up to the ground. So what do they use from Unified Automation? So they use the C++ SDK for all the server development. So in the first step they did like these ground adapters, like the protocol converters from the existing protocol to OPC UA. In the second step, they integrated these servers directly into the experiments and used OPC UA servers directly on the flight side. And in the third step, they activated Pops Up communication because there's nothing you need to do in addition. Like when you expose already all your information in the OPC UA server address space for client-server communication, you can use the same information also to send the data via Pops Up. It's just then a pure configuration task, not a development task. So that's what was the one thing they used from us, and the second thing was the UA gateway. So in the early days, the gateway was mainly used to translate between classic OPC and OPC UA in both directions, but it is also aggregating server, and you can load information models to the gateway. So what they did is they used it to aggregate different OPC UA servers into a single address space and created their own objects, taking data from different sources combine in different objects with different data sources, even taking, like I said, clients writing to data source. Okay. So this is like statement from the engineer that was responsible for the communication integration, and he was especially happy about getting his like additional requirements solved by just having a new feature in the standard and in the libraries, and he didn't really need to do any custom solution for that. So he was very happy that the OPC Foundation thought about his problem years before, and so he's very happy with this simple extension now. That makes his life easier now. And so these are just a few numbers. That's my last slide. They increased the number of like data points they get from one experiment from 64 to 4,000. So that's a huge improvement for them, and they have even much higher data throughput now than before. So the scientists get much more detailed data during the flight already, and before they had to do like everything after the flight they get all the raw data captured during the flight. So there's always a backup, but now they have much deeper insight already during the flight and can maybe fine-tune stuff during the flight. Yeah, and all the all the preparation stuff like system integration, engineering, remote access made like their life much easier and more efficient for all the people involved in the project. Okay, so the complete case study can be found on the OPC Foundation website. So if you want to read more details on it, you're welcome. And let's see what's in 20 years.